Let's be real, modern apps are just swimming in data. We're talking everything from user profiles to real-time analytics, and that creates a massive headache for developers.
So, how in the world do you build a system that can handle this giant, often messy, and constantly growing ocean of information? Well, this is the exact problem a new kind of database was built to solve. And one of the biggest names in the game has a name that pretty much says it all.
You guessed it, the name MongoDB literally comes from the word humongous. It's baked right into its DNA. Its whole reason for being is to tackle massive data sets like it's no big deal. So how does it actually pull that off? Let's get under the hood. To really get MongoDB, you kind of have to forget what you know about traditional spreadsheets and tables. At its core, MongoDB is what's called a NoSQL, document-oriented database. Okay, first key term you need to know is a collection. Now, if you're coming from a traditional database background, the easiest way to picture a collection is to just think of it as a table. Simple enough, right? It's just a bucket for a group of related things. And what goes inside that collection? Documents. And yeah, you can think of a document as being like a single row in that table, and this is the huge difference. It's not a stiff, rigid row with a bunch of fixed columns. It's a super flexible, JSON-like structure that matches up perfectly with the way developers write code. And that, my friends, is a massive advantage. Take a look at this. This is what a document actually looks like. You've got your basic key value pairs. Name is Ellis, email is her email. But check out hobbies. The value isn't just a single word. It's an array, a whole list of things. That ability to store complex data right inside the record is what makes this model so incredibly powerful. So this brings us to a huge decision that every developer has to make when they start a project. Are you going to go with a traditional SQL database or a NoSQL database like MongoDB? The answer really comes down to a fundamental difference in philosophy. It really is a choice between the super structured, predictable world of rigid tables and the adaptable, developer-friendly world of flexible documents. Let's really break down what that means when you put them side by side.
This table breaks it all down perfectly. With SQL, you have a rigid, predefined schema. That means you have to figure out all your columns before you even start. MongoDB, it's totally dynamic. You can add new fields whenever you want. And then there's this one, scalability. SQL usually scales vertically, which means you have to keep buying a bigger, beefier, more expensive server. MongoDB scales horizontally. You just add more cheap servers to share the work. For huge apps, that is an absolute game changer.
Okay, that's enough theory. Let's see what it's actually like to get your hands dirty with MongoDB. We're going to walk through the 4 basic things you'll be doing all the time, and they go by the handy acronym CRUD. CRUD. You're going to hear that all the time. It just stands for create, read, update, and delete. These are the absolute fundamentals for any app that needs to store data. And the beautiful thing about MongoDB is just how natural it makes all of this. Let's look at some code, you'll see what I mean. First up, let's create some data. I mean, look how clean this is. We just point to our users collection, use the insert one command, and then we pass in a simple JavaScript object. Boom! That's it. That's our new document in the database. All right, now we need to get that data back out. To find a specific user, we use find_one, and we just give it a query object that's basically a filter. We're just saying, hey, go find me the one document where the email field is this value. It's so intuitive, it almost reads like plain English. So what if we need to change something? For updates, we use onEupdate. But notice that special $push operator? This is so cool. It tells MongoDB, hey, don't replace the whole thing. Just add a new item, photography, to the hobbies list. It's like performing surgery. It's incredibly efficient. And finally, deleting. Just like when we were finding data, we use a filter to tell it exactly which document to get rid of. The delete one command finds the first document where the name is Alice and just poof, removes it from the collection. So the basic CRUD stuff is super simple and powerful. But what really makes MongoDB the choice for massive professional applications are the features that are built from the ground up for scale and reliability. This is where it really earns that humongous name. Let's just touch on these real quick. Indexing is just like the index at the back of a textbook. It lets the database find what it's looking for instantly without having to read every single page. Replication means your data gets copied automatically across multiple servers. So if one of them fails, no problem, your app stays online. And sharding. Sharding is the real magic for scaling out. It breaks up your massive database into smaller chunks and spreads them across a ton of different machines, which means you can scale almost infinitely.
So, there you have it. We've gone all the way from the name to the core ideas and even the code itself. We've seen how MongoDB's flexible model and its focus on horizontal scaling gives you a powerful way to handle modern data. So the final question to think about is this. As the data in your own projects keeps growing and growing, is this the kind of flexible scale that you need to win?